This is Unit 2, Lesson 4, Estimating Irrational Numbers. We'll start with the bell ringer. The first one says check all statements that are true. If the statement is false, change something to make the statement true. So since 16 is a perfect square, then the square root of 16 is rational. That is true because you can write the square root of 16 as 4, which you can write as a fraction. The next one says, since it's a repeating decimal, 8.7 repeated is irrational. That is false. All repeating decimals are rational. The next one, since 5 is not a perfect square, then the square root of 5 is irrational. That is true. All non-perfect squares are irrational. Next one, since it is a ratio of two integers, 5/8 is irrational. That is false. All fractions are rational. Since it is a terminating decimal, 11.43 is rational. That is true. All terminating decimals are rational. So over on the next problem, it says classify each number as rational or irrational. So 44.51 is rational because it's a terminating decimal. The negative square root of 23 is irrational because it is a non-perfect square. 5 pi is irrational because pi is always irrational. The square root of 36 is rational because that's equal to 6, which you can write as a fraction. And 47.20 repeated is rational because all repeating decimals are rational. Next one asks you to simplify. So we're going to write it all out. So 54 times 6 v's. And then 63 times 2 v's. Okay, I'm going to divide out my v's and then divide 54 over 63, which simplifies down to 6/7. And then there are 4 v's left on the top. The next one I'm going to write out as well. Okay, it's all written out, so now I'm going to divide out the numbers that are in common, and I'm left with 1z and 3 y's. Okay, go ahead and turn to the next page in your notes. So before we start estimating the irrational numbers, let's review what rational and irrational numbers are. So rational numbers are anything that can be written as a fraction. Sorry, that didn't fit. That says fraction. So for example, we could have 2/3 because that's a fraction. We could have -1 1/4, also a fraction. Okay, 0.27 is a terminating decimal, and you can take any terminating decimal and write it as a fraction. You could do 7.3 repeated because repeating decimals can be written as a fraction. Or 5 because you could do 5/1, and that's also a fraction. Then irrational numbers are numbers that cannot be written as a fraction. So that would include any non-terminating or non-repeating decimals. So the most famous example would be pi, or you could have the square root of a non-perfect number or the cube root of a non-perfect number. So today we're going to be doing different types of estimating of irrational numbers. So those are going to be, we're mainly focused on square roots that are not perfect. So we're going to start by estimating the decimal value of the square root of 8. So if you look at your perfect squares chart, the square root of 8 falls in between two perfect squares, the square root of 4 and the square root of 9. You know that the square root of 4 is 2 and the square root of 9 is 3. So you know that your decimal has to be somewhere in between 2 and 3. Now 8 is closer to 9, so your decimal is going to be closer to 3. Okay, I'm going to estimate, like right now we're just kind of guessing, that decimal is going to be about 2.9, let's say, because 2.9 is in between 2 and 3, but it's closer to 3. So then on our number line, I'm going to graph that. Let's put 2 here. 1, 2, 3, 4. This would be 2.5, 6, 7, 8, and that would be 3. So I'm going to estimate that the square root of 8 is right about there, in between 2 and 3, but closer to 3. Okay, we're going to try that again with the square root of 83. So I'm going to look at my perfect squares chart, and I know that the square root of 83 is in between the square root of 81 and the square root of 100. Are the two perfect squares. If I square root those perfect squares, I know that the decimal is going to be in between 9 and 10 somewhere. 83 is closer to 81, so I know my decimal is going to be closer to 9. And I'm going to guess that my decimal, let's just go with 9.1 for right now. Okay, all we're doing is just guessing. Okay, we'll get a little bit more exact on the next page. So let's see. Let's put 9, whoops. Let's put 9 right here. 1, 2, 3, 4, 5. So that's 9.5, 6, 7, 8. And that would be 10. So 9.1 is about right there. So we'll just say that's the square root of 83. Okay, 135. So if we look at our perfect squares chart, 135 is in between the two perfect squares of the square root of 121 and the square root of 144. So 135 is in between those two numbers. It is closer to the square root of 144, but it's not like super close. So I'm going to estimate that the square root of 135, let's go with like 11.6. Okay, it's in between 11 and 12, but it's a little bit closer to 12 than it is to 11. So I'm going to put that here on my number line. There's 11, 1, 2, 3, 4. Okay, so 11.6 is about right here. So that's going to be the square root of 135. Okay, for some reason we have two of the same problems. So the square root of 83 we already estimated to be 9.1. So I'm just going to say 9.1 right there. But let's look at the square root of 100. So I know that the square root of 106. The two perfect squares are 100 and 121. So 106 would go right in between those. It is closer to 100. So I know that my decimal is going to be in between 10 and 11. So I'm going to estimate it to be about 10.3. Okay, now remember that I'm just estimating, I'm guessing right now. So if you guess like 10.2, that would be okay, 10.1, as long as it's closer to 10 than it is to 11. Okay, when you're ready, go ahead and turn to the next page. Okay, we're going to fill out our perfect squares chart here at the top of the page to help us. So I'm just going to write them on here. You can follow along with me or write them on your own. It's up to you. Okay, you can pause the video while you finish filling in that chart. Just double check and make sure all your numbers are the same as my numbers so that you're not using the wrong numbers. So on this next section, the directions say to state the two integers that the square root or cube root falls between, then circle the integer that the root is closest to. So the square root of 35, I'm going to go on the squared row because it's the square root, and I'm going to go down. And I can see that the square root of 35 is in between the square root of 25 and the square root of 36. So 35 is right in between those two numbers, which means that the decimal will be in between 5 and 6, but 35 is closer to 36, so the decimal is going to be closer to 6. Okay, let's do that again on number 2. It's a square root, so I'm looking at the middle row for the squareds. It's in between the square root of 121 and the square root of 144. You need to make sure and pick like two consecutive numbers that it's in between. Okay, so if I know my decimal is going to be in between 11 and 12. And if I look at the distance between those, 130 is closer to 121, so the decimal will be closer to 11. Okay, 102. If I look at my perfect squares chart on the middle row, I can see that 102 is in between the square root of 100 and the square root of 121, in between those two perfect squares. 102 is closer to 100, so I know that my decimal is going to be closer to 10. Okay, the square root of 73, I'm going to look at my chart up here on the second row. 73 is in between the square root of 64 and the square root of 81. So I'll put 73 there. Whoops. Okay, which means my decimal will be in between 8 and 9. And 73 is closer to 81, so the decimal will be closer to 9. Okay, the square root of 68, we're still looking at that second row because we're doing square roots. That's in between the square root of 64 and the square root of 81. So the square root of 68 will be in between 8 and 9 somewhere. 68 is closer to 64, so the decimal will be closer to 8. Okay, the square root of 41, again, we're looking at the second row, in between the two perfect squares of 36 and 49. And if I look at that, let's see, that means it's going to be in between 6 and 7. 41 is closer to 36, so that means the decimal will be closer to 6. Okay, now I'm on cube roots. So I'm going to take this, I'm going to look at the third row now because I'm doing cube roots. So the cube root of 78 is in between the cube root of 64 and the cube root of 125. So that means when I actually get the decimal for that, it's going to be in between 4 and 5. 78 is closer to 64, so that means the decimal will be closer to 4. Okay, let's see. The cube root of 108 is in between the same two numbers that we just used, the cube root of 64 and the cube root of 125. That in there, which means my decimal is going to be between 4 and 5, but this time 108 is closer to 125, so the decimal will be closer to 5. Okay, and the last one on this, let's see, the cube root of 48 is in between the cube root of 27 and the cube root of 64, which means my decimal will be in between 3 and 4. And 48 is closer to 64 than it is to 27, so my decimal will be closer to 4. So take a minute and pause if you need to. You can watch it again, and then let's move on to the next section. You will still need your perfect squares chart. I'm going to kind of do mine without, I guess. So this one is asking you to estimate to the nearest tenth. And you're actually going to be able to use a basic calculator on these questions on your homework. So when you get to them on your homework, you'll see a little calculator that has add, subtract, multiply, and divide. And so we'll talk about how to make sure your answer is as accurate as you can with the decimal without actually typing in the square root to your calculator. So we'll start with the square root of 44. If I look up above, I can see that that square root is in between 36 and 49. Okay, those are the two perfect squares that it's in between. So my decimal is going to be in between 6 and 7, but 44 is closer to 49, so I know my decimal is going to be closer to 7. Now I need to pick a number that is in between 6 and 7, a decimal, but closer to 7. So I'm going to try a few of them. I'm going to list them out over here, 6.6, 6.5, or 6.7. We'll try those two and just see. So on your calculator, that will be on your homework, you'll be able to type in those numbers. So you'll just take one number that you pick, so 6.6 times 6.6. So I got 43.56. So I'm gonna write that down here, 43.56. You know, that's pretty close to 44, that's our goal, but let's try 6.7 to see if we can get a little bit closer. So I'm gonna clear this off and do 6.7 times 6.7, and I get 44.89. So now I just need to determine which one it's closer to. So 44 is in between those two numbers, but it's actually going to be closer to 6.6. So that is going to be our decimal estimate. So 6.6 is as close as we're going to be able to get to the square root of 44. Okay, let's do the next one. So I know that that's in between the square root of 121 and the square root of 144, which means my decimal will be in between 11 and 12, but it is closer to 11. 125 is closer to 121. So I know that my decimal is going to be in between 11 and 12, but closer to 11. So I'm going to try like 11.1, 11.2, 11.3. Let's just see what we get there. So if I pull up my calculator, I'm going to do 11.1 times 11.1, and that's 123.21. Okay, now I'm going to try 11.2. 11.2 times 11.2, 125.44. So I'm a little bit over, so I don't even really need to try 11.3 because I know 125 is in between 123 and 125, but it is closer to 11.2, so we're going to have that one as our decimal estimate. Okay, let's try our next one. So 23.5 is in between the square root of 16 and the square root of 25, which means the decimal will be between 4 and 5, but it's closer to 5 because 23.5 is closer to 25. So I'm going to try, let's do 4.7, 4.8, and maybe we'll need to try 4.9 just to see. So I'm going to pull up the calculator and do 4.7 times 4.7, and that's 22.09. Okay, we're close. Let's try 4.8. 4.8 times 4.8, 23.04. So we're even closer. Let's try 4.9 just to make sure. 24.01, which is too high. So 23.5 is closer to 4.8, so we'll go with that one for our answer. Okay, let's do number 4, the square root of 87. So that square root is in between, let's see, 81 and 100. So my decimal is going to be between 9 and 10. It's going to be closer to 9 though. So I'm going to try 9.2 and 9.3. So on my calculator, 9.2 times 9.2, 84.64. That's pretty low, but let's see what 9.3 is. 9.3 times 9.3, 86.49. And that is pretty close. You could try 9.4 if you want to, but 9.3 is going to be closer. Okay, the square root of 26 is in between 25 and 36, which means the decimal will be between 5 and 6. It is closer to 5. So I'm going to try 5.1 and 5.2 just to make sure. So 5.1 times 5.1 is 26.01, Ooh, and that's really close. I'm not even gonna try 5.2 because I'm not gonna get any closer than that, so 5.1 is gonna be my answer. Okay, 120. It's in between, let's see, 100 and, just 100, right? And 121. So the decimal will be between 10 and 11, but it's closer to 11. So I am just gonna try 10.9. That's as close as I can get. So let's try 10.9 times 10.9. 118.81. And I can't get any closer to 11 without going over, so that decimal is just gonna be as close as I can get. Okay, the cube root now, make sure you're paying attention that we're doing cube roots. The cube root of 56 is in between the cube root of 27 and the cube root of 64, which means my decimal will be between 3 and 4. Let's see, it is closer to 4, so I'm gonna try 3.7 and maybe 3.8. Now remember, when you put this in the calculator, you're doing a cube root, so you have to type the number in 3 times. So 3.7 times 3.7 times 3.7. So 50.65. Let's see if we can get closer by doing 3.8. So 3.8 times 3.8 times 3.8, 54.87. Let's try 3.9 just to be sure. So 3.9 times 3.9 times 3.9, 59.31. Yeah, that's too high because I'm trying to get close to 56, so I'm going to go with 3.8 as my answer. Okay, the cube root of 247 is in between, let's see, the cube root of 216 is one of the perfect ones, and the cube root of 343. So I know the decimal will be between 6 and 7, closer to 6, so I'm going to try 6.2 and 6.3. Maybe 6.4, let's see. So again, remember you're doing cube roots, so you'll have to type that in 3 times. So 6.2 times 6.2 times 6.2, 238.33. 238.33. Okay, let's try 6.3. 250, almost exactly. Okay, and that is pretty close. We want 247, so I'm going to go with 6.3 and not even worry about trying the next one. Okay, and then the cube root of 730 is in between 9 and, so the cube root of 729 and the cube root of 1000, which means the decimal will be between 9 and 10, closer to 9. Like really close to 9, so I'm just going to try 9.1, and I think that will be the right one. Let's just try it. So 9.1 times 9.1 times 9.1, 753.57. And if I went bigger than 9.1, I wouldn't, like I'm not going to get any closer to 730, so that's just going to be my answer. Okay. That was kind of a lot. If you need to pause the video, you can. On this next section, I'm going to have you guys work on it, but what this is asking you to do is basically the same thing you did in the section above. You need to solve the equation. So if it's a square, that means you're going to square root the answer. So 1, 2, and 3, you're going to square root, and then you're going to estimate what the decimal is. And on 4, 5, and 6, you're going to cube root and estimate what that decimal is. So pause the video and work on those 6 problems, and then when you're done, push play, and I'll have the answers up here for you. Okay, there are the answers to those questions. Make sure you have them done and you know how to get those decimals. Again, it's the same process that we just did up on this middle section. You're just picking a decimal and kind of estimating the one and checking to see if it's right by using the 4-function calculator. Okay, turn to the next page. You'll see on your notes that there is another perfect squares chart. This one goes all the way to 20. This is one that you will be ripping out of your packet to use on the quiz when we have the quiz in a week or so. So you need to write neatly on here. You need to make sure that all your numbers are accurate and that you don't lose it before we take the quiz. So I've actually already typed up all the numbers for you. So write these numbers in your packet on this page, page 25, and then just leave it in your packet, don't lose it, and you'll be able to use it on the quiz. So pause the video so that you can write all these numbers down, and when you're done writing, when you're done filling in the table, go ahead and work on your 2.4 homework.